Sitting in front of me here is a Sinclair ZX Spectrum Plus 1 to 8K toaster rack. A very capable machine with twice the amount of RAM of some of the competitors. But if I was to ask you what's the most popular computer of the 1980s, this one, it launched in 1986. But what's the most popular computer overall? Well, it has to be the Commodore 64. And one of the main features of that machine was its sound capabilities. That lay in the SID chip, or the MOS Technology 6581. But what if I was to tell you that we could add a SID chip to this ZX Spectrum? Or at least that's what we're going to try and do today. Because thanks to Sparks UK, he very kindly donated some stuff to me in this box that might just let us add a SID chip to a Spectrum. We have some components and one little board to build. On here we can either install a real SID chip, or this thing can emulate either of the SID chips, be it the 6581 or the 8580. This attaches to the expansion slot on the back of a 128K Spectrum, and supposedly should let us play back SID files, which is SID music files. Now Sparks has built one of these for himself. In fact, he ordered a whole pile of these along with various component kits, and a few other people have tried to build theirs as well, and so far nobody has got it working. The question is though, is it something with the board here that maybe needs looking at, or is it something in the software side? I suppose there's only one real way to figure that out. Let's start by putting this together. There is quite a bit to put onto this, and it is quite a compact little board, so this could be fiddly enough. But let's turn around to the bench behind me. Let's try and put this together, and let's see if we can get a Spectrum to play a SID file. So the board in question then, it is the ZX T-SID Revision D. This is the GitHub for it, and I will leave a link to this down in the video's description. Sparks has provided us absolutely everything we need here to put it together. Well, maybe other than a socket for the SID chip, but I should have plenty of those. Everything else here is nicely labelled up. We have a little box with the various ICs in it. There only are a couple of through-hole components, and then obviously the connector itself. Although we will need to modify this. We need to cut the sides off this so that it will fit onto the Spectrum. We'll do that later though. For now, I'm going to start like I usually do when putting together a project such as this. I'm going to start with the two main ICs. This one is a Xilinx CPLD. This one is an Atmega chip, and I think it is that one which is providing the SID emulation. That is in the form of a SwinSID, and using the jumpers that we will be installing on here, we can set it either for a real chip or an emulated 6581 or emulated 8580. Now, the one thing that sort of jumped out to me straight away is, in relation to those two packages, where is pin 1? Normally you would see like a dot on the silk screen, maybe indicating, you know, the corner where pin 1 is. But there's no such thing here. There are a couple of images on the GitHub that we can use for reference. But I think in the case of this board, the pin 1 indicator is that line there, just beside that pad. Same on that one. And indeed, looking at the picture from the GitHub, it shows the package in that orientation. Pin 1 is that bottom left hand corner there, denoted on this thing by that chamfered edge, and also there's a little circle there just on the top of it. So we need to put that on something like that. And you know what? This might be the perfect opportunity to use this little digital microscope. My wife got me this for Christmas past. It is just a little 4-inch screen on it, but that's because I asked her to get me this one. Just because I am a little limited for space out here. But that will certainly give us a close-up of what we're working with, and just let me see if I can use that to get this orientated properly. Alright, you know what? This is doing my head in. Every single one of those pads has a little bit of solder on it, and it's making it near impossible to align the package, because every time I put it on, the leg of it is sort of sitting on it and then it falls off to one side, and it's just winding me up. So I've put a lot of flux on the board there, and I'm just going to go over all this quickly with a bit of braid. Alright, hopefully that makes my life a little bit easier now, does it? So we'll drop the package back on there. Yes, it does have a lovely blob of solder in that corner where we did try to tack it down, but at least I can now move it around this without it getting caught on anything. So I think we're pretty well aligned at that. Let's try it again, shall we? Bit of flux in that corner where we have that little blob of solder. Let's see if I can get that to flow properly now, and we can get that corner stuck down. Yes, there's still a bridge there, but that's fine. The chip is now secured. Let's just go around and make sure it is orientated okay. And yeah, I am pretty happy with that. So we'll swing around to the other side. We'll just go for a lot of flux across this. Bit of solder on the iron again. And let's see about getting this whole side done. Right, let's just tidy up this bit then. Quite a big nasty blob of solder there. Should be easy enough to deal with. A bit more flux on it. And we'll just dab in and out and clean the iron each time. Almost gone. Yeah, that's it now. One down. Let's get the other package on. Hopefully with those pins being a lot bigger though, this will be a lot easier to orientate. Again, yes, that's a nasty blob of solder, but it's just to hold the chip. Then we can check that the orientation of everything is pretty good. And no, the chip needs to move down ever so slightly, I think. Maybe just wants to move a little bit more. Yeah, that's looking pretty good at that. I obviously keep putting too much solder on the iron. Too much on it to start with. But it is easy enough to deal with. So that's the two main chips on. We're not going to program them yet. I think we'll just leave the programming till the very end. But next then, I'm just going to finish off all the rest of the surface mount stuff on the bottom here. There isn't an awful lot of it, just a few capacitors, a couple of resistors, and the crystal which goes there. For putting this on though, I'm going to pre-tin these 4 pods, even more so than they are factory pre-tinned. And we'll just use the tweezers to hold this thing in position. It does go on in that orientation. I'm going to see if I can remelt that and flow it up onto the legs of our crystal here. So all done on this side. There is a jumper up here that probably needs set, although I think we'll come back to that later. These points here and here, 6 pods there and 10 of them there. No components for those positions, rather those are the programming points for these two things. So yeah, I'm going to have to wind up probably soldering wires to these when it comes time to program. But again, we'll come back to that. Let's first finish putting the rest of this together. And there is quite a bit on this side. Handily enough, more or less all the components, or in fact, I think, yeah, all the components. They are labelled there what they are, but also the value of what they are is all printed on the silk screen. Was the same on this side as well. But it just makes it nice and easy for identifying the location of parts. For example, in that location there, or in fact in both those locations, C3 and C10, those are 10 microfarad capacitors. Tantalum capacitors, that's these things, these do have a polarity, which is identified by the solid line on the capacitor. That's the positive side. And in terms of the outline of the silk screen, we need to match that line on the package up with the closed end of the box there. That has to go on like that. Then the other one just goes on below it. So that is going to be the gist of it. As you can see, I have quite a bit to be getting on with here. Well, that is nearly all the surface mount stuff done. Just one package left to fit, but another problem. So this is the 3.3 volt voltage regulator that needs to go here. It is a part number AMS 1117-3.3, and Sparks has included an AMS 117 regulator here, but this is a 5 volt part, so that is not suitable for this. I wonder, is that the problem that he and maybe some of the other guys have been having? It is very easy to accidentally, make a mistake like that when ordering something. But that 3.3 volt supply, that would be derived for powering presumably the CPLD and perhaps also the Atmega chip. So if you were driving those to 5 volt, I would say you definitely risk damaging these. So I do need to source a suitable voltage regulator somewhere. And it just so happens that I have a faulty one of these. An ESP8266. I bought this for doing a GBS control mod, but this thing is faulty. It will not program. But sitting in the middle of this is the very voltage regulator that we need. So a little bit of hot air will soon get that off. I'm just going to go around that first with a little bit of flux. And indeed, while we have the hot air out, we can just go over a lot of these little passives here, give them a quick blast of it, and that will help straighten them up. So we'll fit that in a minute, but as I said, I'm just going to hit all of these with the hot air, see if they straighten up. There's one there, for example, that's a little bit bent out of shape. There we are, and you see that has sort of jumped into a better orientation now. Right, I'm a lot happier with that. Everything is sitting a lot better looking now. So I'll just give this a second to cool down and then we'll fit that. Okay, so I've just put a blob of solder on that position there where the tab goes. Got the regulator here in the tweezers, so we'll just melt that again and offer this up into location. Just like that. Yes, I did manage to block a hole there. That was a silly thing to do. But then we'll do these other legs. And that is all the surface mounted stuff finished. So just all the through hole stuff to do. That should all go on very quickly. Just going to solder one leg of those and then sort of hold the PCB and push it down into the bench. Remelt that, and hopefully that'll just have everything sitting where it needs to be. Yeah, that looks fine. We're very nearly finished. Just the socket for the SID chip and the connector for the Spectrum itself. And I know I did say I have plenty of those sockets, but yeah, while I have plenty of sockets, I don't actually have any in that size. So instead of using a socket, I'm just going to use this strip of like turned pin header socket things, and that will go in there to that point. These were very kindly donated to me by Cavanos. He sent me a big box full of goodies. Lots of various bits and pieces in here, including various types of pin headers and bits and pieces, but some other extremely cool stuff. That is for another day though. Now, just to make sure that I install these straight, I am going to put this socket, which is too small, I'm going to put this socket into those. And that should just hold everything in the correct orientation for us while we solder it up. And so it's just this thing. But as I said earlier, we need to take the sides off this so that it fits on the Spectrum. Because the edge connector on the Spectrum is just part of the main board. You know, it doesn't stick out of the board. It just sits flush with it. So to get this on, it needs a slot in there and a slot in there. But rather than try to cut slots, I'm just going to take it straight off there. I've just put this cloth down here to try and catch any of the mess, and I'm going to use the Dremel, or the little Dremel knockoff, to try and cut this. That should work okay like that. Although I've maybe taken too much off that side, have I? Oh, silly boy. Yeah, that is leaving those pins exposed on that side, and they're just flopping in the breeze now. Right idea. Just poor execution. And that looks a bit better. So these were 60-way edge connectors that I had bought for another project, but I just took one of them and trimmed it down. In a similar sort of fashion, you have to remove 2 pins in one location there because the thing is keyed. So let me just tidy this up and then we'll solder this on. So it goes on this side with the CPLD and AppMega facing the Spectrum, and you can see there the way it is keyed. So it goes on like that. Just check that it is indeed sitting okay. And yeah, that does look pretty good. So I'll just prop it up again here, and we'll get all this soldered up. We'll start by programming the CPLD, and as per usual, I'll be using the Raspberry Pi to do that. But the one thing that is slightly different on this board, the programming points are just these pads here. When you've seen me doing this before, say on the Terrible Fire board, it has been holes in the board, and we've been able to stick like a pin header through and wedge it into position, and that does for programming. But that's not really going to be an option here, so I think the best thing to do will be to take another set of wires. I'll cut the end of one of these. We'll make that off onto the various points on this. It's just going to be those pads on the bottom row, TCK, TDO, TMS and TDI. There are pads there for VCC and ground, but I'm not going to try and power this from the Raspberry Pi. Rather, I think what I'll do is actually put this into the Spectrum and power it up that way. Okay, this is all hooked up and ready to go. As I said, I'm going to power it from the Spectrum. Now I'm going to use my 48K Spectrum to power this from. We're not going to be testing this with the 48K Spectrum though. Rather, we do need the 128K Spectrum to do that. But the reason I'm not jumping in and powering this with the 128K is because, well, I don't own that machine. I do own this one. So if anything goes up in smoke here, at least I'm damaging my own machine. Now, as I said, this thing is keyed. Ideally, we would have something in there to force this to go into the correct location. You can see that the PCB has a slot cut out in it there. And I suppose I will need to get something in there before we finish off, but let's just try and wing it for now. So this is currently live. Watch out for any magic smoke. And everything does seem okay there. Let's just bring in the multimeter quickly. Let's just be sure that we are indeed getting power there. I'll try and measure it on the voltage regulator. So it's just reminding myself of the pin out there. Pin 1 is ground, and the middle pin is the output. And yeah, a nice steady 3.3 volts. So let's see if this programs. I am connected to the Pi here over SSH. The command is ready to go. Let's see what this does. No JTAG chain found. So yeah, two dumb things there on my part. We need to have a ground connected, so I've added that as well. But also that command I was trying to run, I had that typed in wrong. But I think that's it all now, so hopefully this should now work. And yeah, away it goes. Successfully programmed. Next thing to do is the @mega, but we won't be using the Pi for that. Rather, we'll be using this thing. I've moved the wires over to the programming pads for the @mega, but I've added this red one here for VCC. We're going to just power this from the TL866. Now, when you see me using this previously, we've been using the ZIF socket here. But this time we obviously can't do that. We're going to be using this port on the side of it, the ICSP port. So if we jump into the XG Pro software, we need to find our chip, which is an @mega 88PA, and it is the TQFP32 package. We need to select this because we're using the ICSP port. And if we load the file associated with the SwinSID, it is this hex file. There's actually two different versions of it, but let's start with this one. And we'll open the program dialog, and that's because that gives us the pinout for how to connect this up. So working left to right on this, position 1 is reset pin. From this thing, that would be my green wire. There's then VCC, which I have as red. Then ground, which is the brown wire. Then MOSI, which is the blue one. Then it's MISO, which is the yellow one. And finally SCK, which should be the orange one. And yep, that's right. It doesn't apply a voltage to this until you actually hit program. So let's just do that, shall we? On one programmed SwinSID. And that's it. We are ready to test. I do need to set some jumpers though. And I think initially we'll not bother with a real SID chip in here. Let's try the SwinSID that's built into this. And I think for that, all I need to do is set jumper 1 to position 2, 3. So that position there. And I think we'll take the 6581, and for that I need to close jumper 2. These other jumpers we will need to set later if we're going to try and use a real SID chip. I want to quickly go back to those voltage regulators. And yes, the one that Spark sent is definitely a 5-volt part, so not suitable for our board. But I wonder what voltage it would output if we input just 5 volt to it. I mean, maybe it's outputting 3 point something volts, and while not ideal, would probably be safe enough for short-term use anyway on our SID board. So I have it hooked up here in this rather sketchy looking rig. The multimeter is set up here, connected to this, waiting to show us what voltage that is outputting. And we even have snorkers watching over everything we're doing. I'm not really sure where that badge came from. He did send that to me ages ago. and while I was setting this up, this just appeared. He is well known for his Spectrum stuff, so maybe he just wants to see what's going on. So the bench power supply, let's set it to, in fact, you know what, let's set it up. Let's set it to say 8 volts, and let's just confirm that this thing is indeed a 5-volt regulator. And yeah, okay, 4.98 volts output, definitely a 5-volt regulator. But if I now take that down to 5 volts, so 5-volt input, what is it going to output now? And 4.13. So yeah, still higher than the 3.3 required by the CPLD. And indeed, yeah, checking the datasheet, it has a recommended maximum input voltage of 4 volts. So we're slightly higher here, 4.13. With that on the SID board, it's probably not going to damage anything straight away, but definitely would be worth getting that replaced at some point in the future, I would say. Some point in the near future before it does damage something. And let's test it. Now we're going to be using the 128K Spectrum this time. That's because the software that we're going to use for playing back a SID file, it needs a 128K Spectrum as a minimum. But because this isn't mine, you can see I have added a key in here just to be sure that we get everything orientated correctly. I actually took that out of one of the other Spectrum expansions I have. It's just like a staple or something that somebody has bent to shape, but it serves its purpose. So this will go into the expansion slot. I have composite video hooked up to the capture card, but let's hook up sound as well directly from the SID card, and let's see what it does. Well, it makes a god-awful sound, that's what it does. It's squealing at me. Why is it doing that? Yeah, that's really annoying. So what is going on? I think we did everything correctly. Maybe we should try that other firmware, but there are 2 trim pots there. Doesn't really give you any information on the GitHub as to what they do. If I had to guess though, I would say they're probably just volume control for the output. That is a stereo jack. Yes, the SID chip is mono, but I would assume they're just taking the mono audio signal and splitting it into like a pseudo stereo or dual mono, whatever you want to call it. I suppose we could just give those a quick tweak just to see whatever they do. So I'll turn them down a bit there. And let's apply power again. And yeah, still squealing, but it is squealing ever so slightly quieter. Those must be volume controls. So yeah, firmware swapped over, but it still makes terrible noises. I did notice though, if you move JP1 into position 1, 2, so as if we were installing a real SID, now granted we haven't set the other jumpers, but with that in there, the SwinSID is disabled, and it's now silent. So the problem must be associated with the SwinSID side of things. I am tempted, you know, to just fit a real SID chip, just like this one, a 6581. Yeah, let's give that a go. So we do need to set the other jumpers for the real 6581. JP1 moves to position 1, 2. JP3 is set to positions 2, 3, and then 4 and 5 are both set to position 1, 2. And that is just how I have all of this. JP3 would seem to be the voltage selection. And it says +9 there and +12 down in there. The SID chip does require 2 voltages. That varies between the 2 different models of this, but this one, the 6581, it needs 5 volt and 12, so that's why that is set as such. Now we do need to put this in here. It is orientated with pin 1 to this side. Just need to be careful obviously, because those are turned socket holes there that I fitted. Need to be sure that everything is orientated correctly for going in here, because I do find when you're putting in these flat pins into those turned holes, it can be very easy to bend them. But I think that's us in. So let's see what it does now. And let's give it some power. Yay, no nasty noises. So that's a result. But does it actually work? Well, for that, we're going to need some software. So this is where things get slightly more complicated. The software that we're going to try and run, it is the NSID Player Pro. And in particular, it's the version for the hard SID on port XXCF. That is where this card presents the SID chip. That is getting hot. That is almost burn you hot. I hope that chip will be alright. But if we download the zip file associated with that, and as you can see, there are various versions of this software. Now, most of them have a file extension TRD, and that is a TR-DOS disk. But we can't run that because I don't have anything that will read one of those disks. Now, if you have the DIV MMC, that supposedly can read these disks, or there are other disk drive emulators for the Spectrum, or indeed other disk drives for the Spectrum that can read TR-DOS files, but we can't do that. So we're going to be stuck with this one, which is a TAP file or tape file. The other thing I would point out as well here is that other than the one I have selected there, the TAP file, saying it's for a 128 slow, as in a Spectrum 128K, all the rest of these are designed for modern Spectrums, well, other than the one for the +3, but the rest of them are designed for a modern Spectrum. Those things have a faster processor in them, or certainly have a processor in which you can select the clock speed. No such option here. This is the original hardware, so I just wonder what this will play back like. There is only one way to find out though. So we'll extract the TAP file, but to play the TAP file, well, I'm going to use my computer to do that. I want to use Audacity to do that. And so we first need to convert that TAP file into a WAV file. For that, we're going to use this bit of software, TAP IR. So we can load the tape file. That's it there. We can then play to a WAV file. Let's just call it SID.WAV. As I said, I'm going to use Audacity to play it. So we'll drop that in there. Let's zoom into it a bit. And first of all, let's just be 100% sure that the Spectrum is indeed listening to the PC. So we'll go into the tape tester. And let's play some of this tape. And yeah, that's okay. The light blue box that has moved up there, that is it reading okay. So we'll reset our WAV file. We'll reset the Spectrum. We'll go into 128 basic. And upside down here, I will have to type load, or D, right there. 2 of those, hit enter, and play. Now the output from the SID card I have going into these speakers now. The Spectrum has found the NSID software. So let's just see what it does. Well, there's our NSID Player Pro. That's good. An option there for load at the bottom, which is number 1. Options 2, 3 and 4 have nothing against them. How do we actually get this to load a song? The tape is still playing away, but there's no more activity in the border there, which, I don't know. Does that maybe suggest that it isn't loading? Maybe I need to press 1. No, it doesn't seem to be doing much. Give me a second to have a play with this. So I've just tried adjusting the volume of the tape that's coming out of the PC. That's one of the problems trying to load things like this. You're never sure if it's a volume issue or if there is maybe just something wrong with the software, or maybe something wrong with my board here. Maybe, you know, there's a lot of variables. But let's see if it does anything different now. I have increased the volume. Okay, there's our menu again, and this time it is continuing to load. And we've got, is that a song? Heaven? I don't know, I would assume so. Certainly not one I'm familiar with, but is it going to start playing by itself, or? I assume it's currently loading that song now. And okay, let's give us some information about the song there. Oh! Hey! It's making noises! Let me see if I can turn this up. Awesome! It's working! I don't believe it. So, the software itself, that's saying there that it's playing back on 8580. That's definitely not right. This is 6581. So press 1 there and that changes that. So let me turn that down a bit. It is a bit loud. It has correctly identified that I'm running everything here at PAL. Well, if we press 2, that changes it to NTSC. And that does sound a little bit faster. Back to PAL. I'm not sure what 3 is there. VB 150 or 160. That makes it considerably faster. And 4 is auto. Funny, pressing that reverts the thing back to an 8580, but that is definitely a 6581. But outstanding stuff, it is working. Here's a question though. How do we get it to load another song? Right, okay, I just pushed down and that has took us back to that sort of menu. And we do have an option there for load. So if you look at the structure of the WAV file, I'll take it back to the start. So it loaded these segments first. And then when it got to here, as it started this short segment, that brought up the name of the song, and then this longer segment beside it, that must be the data for the song itself. So if I put our cursor to there, and if we try to play again from there, let's press 1 for load, and press play. Yeah. So we now have a different song. Let's let this load and try it. Okay, this next song loaded. fantastic stuff. I'm so happy. Although that doesn't sound right. That almost sounds like we're missing channels. Why is the border blue now? So I discovered that to load the next song, you don't need to press 1. You just go back to that menu and start playing the tape file again. And I've also discovered why we had a blue border in the last song. That seems to manifest when the little spectrum here, when it can't keep up to the playback. And this song makes it quite apparent. So as you can hear at the minute, it is playing back fine. But when it starts to get into it there, well, there's that blue flashing border. And as you can maybe hear, the song is starting to stutter. So maybe it is the case that our SID card here, and maybe more so that NSID Player Pro software, it is more intended for the modern spectrums, those modern machines that can run faster than these original ones. But you do have to admit, it is still pretty cool, isn't it? A SID chip hanging out the back of a ZX Spectrum playing SID files. In fact, I think it warrants a bit of a light show. But our SID chip, that is screaming hot. Let me check something. So ground is pin 14, or that one, and VDD, or 12 volt in the case of the 6581, it is pin 28, or that one. And that is pretty much bang on 12 volt. So no issues there. I know these things do run hot. In this case, it seems to be running extremely hot, but I suppose it's maybe just the way it is. So we do have one mostly working ZX-T SID expansion. Still not sure why the onboard SwinSID, why that's not working, but there is one other thing that I would like to try just quickly. I've got this hooked up to the TL866 again. And that's because I was having a look online for information around programming a SwinSID, and I found one reference referring to programming the Atmega using a hex file that contains the binary data. Now, when we loaded that hex file previously, I left all these settings here as default with the file format as an Intel hex, and that is what you see on the screen there. But if we change it to a binary, I wonder if we try and program that. Is that maybe the difference? Is that maybe what I did wrong last time? I suppose there is only one way to find out. Nope, it's still not working. So I thought I'd also check the clock, just to be sure that that crystal is working fine. That's 32 megahertz and it's solely feeding the Atmega for the SwinSID. And yeah, there it is, 32 megahertz, nice and stable. That is fine. And equally, I have compared the schematics between a standard SwinSID and the one that's built into this. They're both identical. So all I can really put this down to is either those Atmega chips that we have here, those are faulty, because Sparks has confirmed he's built his and it's doing exactly the same thing. It just squeals at him when he enables the SwinSID. So it's either those chips are faulty, or maybe we're using the wrong hex file. Although, to be honest, I don't really see how that could be the case, because on here, the SwinSID that's built into that is just identical to, a separate one you would put into your Commodore 64. So I don't really see how the hex file itself could be any different. So I think that'll do us for today. No, not quite, because I think I might have just figured it out. I did actually have this video finished. It was uploaded to patrons and all, but just this morning I was having another think about it, having another look over all the SwinSID stuff, and it seems I might have been doing something a little bit silly, wouldn't be like me, might have been doing something a little bit silly when it comes to programming the Atmega. Well, we're back hooked up to the TL866 once again, but this time I think I've cracked it. And I'm sure some of you must have been screaming this at the screen earlier on while I was trying to program. But if we jump into the XG Pro software, well, you can see here I have loaded the hex file again, and this is it loaded just as an Intel hex. That is the correct way to load it for programming one of those chips. But last time, that's all we did. We just loaded it and programmed. That was, however, missing out a step. Because if you look down here, I see configuration information. Well, I just totally ignored all that last time, assuming that the configuration, which is set in this tab, assuming that when you load the hex file, that would set all that up for you. But no, it doesn't quite do that. So if we take a look on this website, this is a build guide for the Nano SwinSID. And if we just scroll down to this section, this is where it deals with the programming. Now, granted, this guide is using a different bit of software to us, but there's two bits here in particular, the fuse configuration and the lock bits. So if we take a look at the fuse configuration first, we can see there that the fuse registers need to be set with values of 0xF9 for extended, 0xDF for high, 0xE0 for low, and on the lock bits, that needs to be set to 0xFF. Now if we go back to XG Pro, well, you can see that the low byte there, that is currently set to 0x62. That is incorrect. It needs to be 0xE0. Although the high byte, the fuse byte and the lock bit byte, those are set correctly. 0xDF, 0xF9, 0xFF. So we need to alter the low byte, and we do that up here, turn that off, turn that on, and it's now set to 0xE0. So hopefully that is it now correct. Program. Let's test it. So the first test has to be, does it still squeal at us? And no, this time it dinged, and that's exactly what it's meant to do. This is looking really good. So we don't actually have to go into 128 Basic and type load. We can just go into the tape loader directly from that main menu. And let's start the tape playing. Still just running it through Audacity. Same as before. And there it goes. Program NSID. Give it a minute to load, and hopefully this starts playing. You know, I'm just thinking, the fact that the SwinSID makes that ding as it powers on, I wonder if the noise we were hearing earlier was the SwinSID trying to start but not getting anywhere. You know, it was trying to play that little sample and just getting stuck on it. That's why it was creating that constant tone. And the reason I say that is because those low bytes that we had to change there, that we had to set, those are associated with the clocks. And setting those, as I understand, tells the Atmega to use its external clock. In this case, its external 32 megahertz clock. Which in itself, I found out today was, well, an interesting sort of thing. Because all the data sheets for those Atmegas say they're only rated to 20 megahertz. Although it does seem to be the case, it runs happily at 32. So our software has came up. There's the song currently loading. Will it play? Oh yes. Oh yes! It's only working! Oh no way, how stupid was I earlier not to have that configured properly. Yeah, I'm sure some people were screaming that at the screen, but it's working now. That is awesome. And this time you're listening to a direct capture from our ZX-T SID here, using its inbuilt SwinSID. This is awesome. And you know what, on that direct capture, it sounds fantastic as well, doesn't it? And so there we are, one now fully working ZX-T SID. I really can't believe just how simple it was in the end. Just a configuration issue in that XG Pro software. But I've never worked with those Atmegas before, so how was I to know? Yes, okay, you might say read the instructions, but whoever does that? Plus, look at all the fun we had figuring it out as we went. I want to say another massive thank you to Keith, who owns this Spectrum that we've been using today. He very kindly let me hang on to this for an extra couple of weeks. We did some modifications to this in the last video, but he was kind enough to let me hold on to it so that I could get this built. As I said, I only have the 48K Spectrum and it can't run that NSID software. Although I do have another project in the works that might let my 48K run that NSID, might let it use this thing, and so make sure you're subscribed to catch that future video. And to Barry, or Sparks UK as he's known online, massive thank you there as well for sending us the T-SID in the first place. A lovely little expansion. Whoever thought we would see a Commodore SID chip running on a Sinclair Spectrum? And yeah, okay, you might say it's just a bit of a novelty item, because, well, outside of that NSID player, I'm not aware of anything else that would make use of a SID chip on a Spectrum. But equally, it could be argued that most everything we do in this retro computer hobby, it is just for the novelty of it. And yeah, this little card certainly ticks that box. So that is going to be it for this one. Hopefully you enjoyed what you've seen. If you did, I would appreciate a thumbs up. Why not hit subscribe if you haven't done so already? Still plenty more yet to come here on CRG, and I'll see you next time.